Electromagnetic waves are formed when an electric field pairs with a magnetic field. The magnetic and electric fields of an electromagnetic wave are perpendicular to each other and to the direction of the wave. Radio waves!
Radio waves were predicted by James Clerk Maxwell in 1864.
But radio waves were first demonstrated by Henrik Hertz in 1887.
But what are radio waves?
Radio waves are the largest waves in the electromagnetic spectrum.
Oh wow, lovely. I heard they have frequencies from 300 gigahertz to as low as 3 kilohertz.
You are correct indeed, Vrum. Radio waves naturally occur by lightning or astronomical objects.
Oh cool, so does this mean pulsars emit radio waves? And how fast do radio waves move?
Pulsars do indeed emit radio waves, along with solar flares and sunspots. And along with everything else in the electromagnetic spectrum, radio waves move at the speed of light through a vacuum.
That is awesome. What do us humans use radio waves for?
Radio waves can be found in radio communication, broadcasting, radar systems, communication satellites, computer networks, and the list goes on.
Wow, radio waves seem like an important part of our modern day technology. What other kinds of waves can you tell me about?
Yo, bro.
Microwaves are so cool, I love microwaves.
I guess we should go in order, from largest to smallest, so next would be microwaves.
Like what I use to heat up my mac and cheese?
Not quite, but microwaves are a major factor in microwave ovens.
Oh cool, what else can you tell me about microwaves, Rum?
Well, along with other waves, Henrik Hertz was the one to test James Clerk Maxwell's prediction on them. Radio waves' wavelengths can be measured from centimeters up to feet. The longer ones are also capable of penetrating haze, light snow and rain, clouds, and smoke.
So, does that mean radio waves help us see through nebulae?
They sure can. That's a major factor in how we have come so far in our astronomical research throughout our visible universe.
Awesome. So what else can you tell me about this cosmic radio wave background radiation I've heard about?
Oh golly, what can't I tell you is the real question. But cosmic microwave background radiation fills our universe, and it is one of our biggest clues to how the universe started in the Big Bang Theory.
That sounds extremely interesting. A little bird told me that the shorter radio waves are used for the Doppler radar and are just a few inches long.
You seem to know your facts. We should move on, though. We have much more to talk about.
Oh my god, it's an infrared wave!
The next smallest wave in the electromagnetic spectrum is infrared. But I don't know much about infrared. What can you tell me?
Well, infrared lies between the visible and microwave sections of the electromagnetic spectrum.
Cool. What are the different types of infrared waves?
There are near infrared and far infrared.
Well, what's the difference?
Near infrared is closest to the visible light, and far infrared is closer to the microwave region of the electromagnetic spectrum.
Oh, so far infrared is thermal, and near infrared you just can't feel.
Good job, Reb. You got it, dude.
How does infrared waves affect us?
Well, the sun emits infrared waves, but luckily our atmosphere blocks them. It has also helped us find the distance to the moon and map Venus through cloud coverage.
Oh, wow. So to conclude infrared,
James Clerk Maxwell predicted it in 1864, but Henrik Hertz demonstrated it in 1888 and has frequencies of 300 megahertz or 0.3 gigahertz to 300 gigahertz.
I wish I was ultraviolet.
So what's the next smallest, Brum?
that would be ultraviolet, ranging from 10 nanometers to 400 nanometers in a spanner of sun's deadly rays.
So is that how we get tan?
Partially. There are three categories of ultraviolet waves, A being the most harmful, B being moderately harmful, and C being almost completely blocked out by our ozone layer.
So A would be the cause of the deadly disease melanoma and results of too much sun exposure.
B is how we get our almost harmless occasional sunburn.
And C may be the most harmful, but we are not affected by it because our ozone layer almost completely blocks it out.
I think that just about sums it up for ultraviolet light.
Okay, so let's move on now.
shine bright like an X-ray.
The second smallest waves in the electromagnetic spectrum are X-rays.
Oh, are those what we sometimes get at the doctor's?
They are indeed. X-rays are shorter than visible light and range from 1/100th of a nanometer to 10 nanometers.
Gee whiz, that's small.
Yes, but unfortunately, X-rays may be helpful for doctors, but they are pretty harmful to us humans.
How can we prevent getting harmed by them?
Well, lead blocks X-rays, so when we do go to the doctor to get X-rays, they put a metal vest on us.
Oh, that's good. So what objects can emit X-rays?
Great question, Brum. Black holes, neutron stars, supernova remnants, stars, and much more.
Oh yeah, I heard we recently found that even comets emit X-rays.
This is true, but our Earth's atmosphere is far too thick for any outer space X-rays to penetrate through. But unfortunately, this means we can't practice X-ray astronomy from the ground.
Awesome! What's our final wave, Brum?
That would be gamma rays.
Hi, I'm a gamma ray, and I'm gonna kill you.
The final wave in the electromagnetic spectrum are gamma rays.
So what can you tell me about gamma rays?
Well, personally, I find gamma rays most interesting. With frequencies above 10 exahertz and highest form of light, gamma ray bursts can release more energy in 10 seconds than the sun will in its 10 billion year lifespan.
Holy moly, sounds dead.
It sure can be. A neutron star whose mass is 500,000 times greater than Earth, as just the size of Brooklyn, New York, emits gamma rays. But when it bursts and creates a quasar, it is the most powerful and deadly rays in our universe.
So how far can these rays travel? Will they ever hit Earth? And how will we be able to know when they're about to burst?
First, these rays can travel billions and billions of light years. 2, it sure can hit Earth, and these rays did hit Earth about 100 years ago, but it was too far away to really affect us. And last, we don't know when a pulsar will hit Earth, because we don't know when a supernova or quasar will burst.
Oh wow, gamma rays are scary.
They sure are.
Hey, this is Camel.
And Camel.
And we out here.
And we out here.
And we're just making a video.
We're just making a video.
And we just decided to make this one.
We just decided to do this.
Who is the life that we should know by now? Is it
Dun 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 dun.
just a sound?